Here I want to share with you some audio signals generated with our approach. Our method takes two arbitrary audio signals and adapts the acoustics of the first signal based on the second one. First, let's look at the example where our model transforms the sound from the larger reverberant space, like this empty white room on the left, to a smaller space with less reflections, like this cozy bedroom on the right. So first, let's hear the sound recorded in the big room.
There's nothing I can say.
And now let's hear another sound that could be recorded in a small room.
They were raised in the European Court of Human Rights.
Now our approach uses these two signals to change the properties of the first sound, the content sound. So here, let's hear how it sounds.
There's nothing I can say.
And finally, we can compare the processed signal to the ideal signal from the cozy bedroom. We call it a target because this is what we would like to achieve with our method. This is how it sounds.
There's nothing I can say.
So, to wrap up, we went from this
There's nothing I can say.
to this,
There's nothing I can say.
and the ideal signal is this.
There's nothing I can say.
Now, let's look at another example where the transformation goes the other way around. So now we go from the smaller room to the larger room. So the method has to add reverberation, not remove it, as in the previous example. First, let's hear the sound recorded in a smaller room.
We have to look at everything before we...
Now let's hear another sound recorded in the larger room.
I was shaking on the blocks.
And now we will hear the sound generated with our method.
We have to look at everything before we...
And we can again compare it to the ideal case.
We have to look at everything before we...
So again, we went from this content sound
We have to look at everything before we...
to this prediction,
We have to look at everything before we...
and this is the ideal case.
We have to look at everything before we...